After Easotope calculates results in a data analysis, it shows those results in a results table. I wanted to show you the functionality of the results table because some of it's a little non-obvious. There are two tables on this screen. This table up above here is the acquisition table. This is a table where we dragged and dropped data from the mass spectrometer and it's being displayed here. So no calculations are actually being done here other than these simple mean standard deviations here. The table below is actually the results table. So data was taken from these acquisitions and then various calculations, corrections, things like that were done to the data, and then the data was displayed down here in the results table. You can see the results table looks a little different than this table, so it's easy to identify. The first thing to notice about the results table is that it's not really a table at all. It's actually a tree, so you can collapse and expand different layers of the tree. Over on the left, you can see there's row titles, and each of these titles tells you what level of the tree you're currently at. So here at the lowest level of the tree, we have the C level, and C stands for cycle. So each of these rows in the table shows you data for one cycle measurement of the mass spectrometer. This may contain data that we got from the mass spectrometer, or it may contain data that was calculated by Easotope and added to this particular cycle level. So we have 11 cycles here, and those cycles are under the A level, and the A level is the acquisition level. You can also think of this as an aliquot level. This is the level that files are actually dragged and dropped from the mass spectrometer. So this is the file level. So when you take a file from mass spectrometer, drop it in, you're creating an acquisition, and that file is going to contain many cycles. On top of the acquisition level is the replicate level. A replicate is a combination of many acquisitions. So just like an acquisition is a collection of many cycles, a replicate is a collection of many acquisitions, and that's how the tree of data is created. You may also see in other result tables, you may see other levels on top of this. For example, there's an S level. S stands for sample. Sample is a collection of many replicates. On top of that, you may see a P level, which is the project level. So a project can contain many samples. And on top of that would be the U level, the user level. So a user can have many projects, projects can have many samples, samples can have many replicates, replicates can have many acquisitions, and acquisitions can have many cycles. And that's how the tree of all your data is represented inside of Easotope and can be displayed in this table. Some simple things about the functionality of the table. You can make the columns sizes different. If a column is too small to show the data that it contains, you can hover over it and get more detailed information. But often it's easier just to expand it to the right size. You can change the order. So for example, if I'd prefer to have this value over here, I can drag it and drop it and it appears there. So that's easy enough to do. And of course you can scroll back and forth, and like I showed before, you can collapse the tree. That's all the functionality you can do with the mouse immediately in the table, but there's also table commands here above. For example, you can pull up a column selector and you can see an overview of all the data that's available for this particular table. On the right here we have a list of columns that are visible, and you'll see that these columns here are the same as the columns that we're seeing over here. On the left we see a list of columns that we do not see in our table. These columns are available but are currently being hidden. So for example, if we're interested in our 44 voltage background that we got from the mass spectrometer, we can just take that and move it over to this list, and now we see the first column of our table is that voltage 44 background value, -3 at the acquisition level. The arrows here also allow you to move it around. So the 44 is now over here because we moved it. And you can organize the table any way you want. You can select what data you want to see, what data you want to hide, and what order you want to see it in. So let's say we're interested in adding our cap 47 value to this. Maybe our cap 47 is what we consider the most important for our research. So we take out the V44 and we find the cap 47, and here's the cap 47 final value. I add it here, and let's make it right after the analysis status. So it's the fourth column in our table. I click done, and now we've redefined how we want to see our table. Actually, maybe I also want to get rid of these analyses. This is not so interesting, so let's move that over and say done. And now to tidy things up, we'll also hide the cycle level and then hide the acquisition level so that our table's a little clean. We only see the level, the replicate level information, and we see the cap 47 right up front. Okay, now let's say we've reorganized our table now and we want it to stay this way for the future. We can go to Save Table Layout, and now that layout has been saved under our name in our preferences in the database, so that any future tables that we open that fit this particular table context will look like that. So for example, I click on this one, I just opened another replicate, and you see the format of that replicate is the way that we just defined it. The cap 47 is right up front, the analysis fields are gone. So the table, Save Table Layout will allow you to design the table the way you want it, to see the fields that you want in the order that you want with the column widths that you want, and save that for the future. So every user can have everything customized the way they want. Another thing to note is the formatting. You'll notice that the numbers here have been rounded to a few decimal places. This can be disabled so that you see the entire values, or formatting enabled so you see it in a more useful, a more friendly way. The way Easotope works is it calculates all the numbers using their full precision, and then only rounds when it displays them to you. So in the calculations in the background are all happening at the highest resolution possible. The last thing in the menu to show is the export functionality. So let's expand this so we have a little more data to export. So now we have a table of information. We could just grab an area and then copy paste that into another spreadsheet if we wanted to. Or we can use the export functionality built into the table. We click export, and it asks us where to save the data. We can put it on the desktop, save, and the data has been saved on our desktop. That data is now, this file here can now be imported into Excel, and you'll get all the data that was in that table, all the including the row titles and the column titles, and the data inside will all be in the Excel spreadsheet. So you can export from any results table into Excel. The last thing to mention here is a little bit about the column titles themselves, so you can understand the column titles. What Easotope is basically doing is taking data and it's adding new columns to the table. It's calculating new things from the original data. For example, it reads in voltage data from the mass spectrometer, and from that it calculates these delta values. It does various corrections to these values and then spits out an answer at the end. So all the data, every step of the calculation is available in the table for you to look at if you choose, or you can hide it like we showed before. each of these columns is named in a way that the data is easier to find. So for example, if we look at the column title here, we have our carbon values. The second field tells us the scale, so we're using the PdB scale to measure these carbon values. And then the parentheses after it indicate the most recent correction that has been done to this data. So these are carbon PdB values that have been corrected for pressure baseline, using the pressure baseline correction. If you see an SD or an SE at the end, that just means standard deviation and standard error of this column. So here we have a column, here we have the standard deviation, here we have the standard error of it. You can also see there's another carbon PdB value here, and it says final. Final is the word we use after all corrections are finished. So these are the carbon PdB values after PBL correction, and these are the carbon PdB values after drift correction. So the analysis first calculated these, then used these to do a drift calculation, getting this value, and that is our final value. So if you want to see values along the way in the correction process, look for things with words inside the parentheses. If you want to see only final values after the correction is finished, you only have to look for this final word, and that will tell you which value is the final value after all corrections have been done.